Good day, my name is Camryn Terblanche and thank you for having me. I'm delighted to share my research with you today, titled Human Spoofing Detection Performance on Degraded Speech. Over the past few years, a lot of attention has focused on the automatic detection of spoofing in the context of ASV. Although ASV systems have advanced so much in the last few years, they may be susceptible to spoofing attacks, especially considering how individuals can now realistically clone a voice, often by using easily accessible open-source speech synthesis technologies. Due to the viability of fraud in this manner, it's also to be expected that suspects of a crime may claim that a recorded voice is not their own when seeking to exonerate themselves. The lack of insight regarding how well humans perform at detecting spoof speech, particularly under degraded conditions, motivates this current study. ASV technology has become more widely available and reliable. This means that ASV is often used in forensic casework, especially in combination with auditory, acoustic, and phonetic methods. Recently, Wang et al. In 2020 considered ASV and human perceptions of authenticity. They found that some spoof data could not be differentiated from the genuine utterances, even by the human participants. However, Wang et al. Did not consider forensically realistic conditions. As you know, COVID recordings used in forensic casework are often of poor quality due to distortion, limited bandwidth, or as a result of substantial background noise. Schmidt-Nelson and Crystal in 2000 compared the speaker verification performance of human listeners to that of ASV systems, and the results showed that under degraded conditions, human performance was more robust. However, 21 years down the line, can humans still outperform ASV systems when the audio is degraded? Channel degradation affects speech in various ways. When we consider GSM communications, studies have shown that speech quality is degraded due to both the limited frequency range as well as the Lombard effect. Concerning VoIP speech, studies show that the voice quality is affected by interference in the speech signal as a result of packet loss, delay, and jitter. Looking at background noise, we know that humans can filter out unwanted speech and sound in noisy environments due to the cocktail party effect. However, studies show that when individuals are listening to audio with little contextual information, it can be challenging to filter out noise and other speech due to the masking effect, when noise interferes with the speech signal. Our study had two research questions. To what extent does channel degradation and synthesis quality affect the judgments of genuine and synthetic speech by human listeners? And what listener factors affect performance at recognizing genuine and synthetic speech? The aim of our study was to compare synthesis quality, common types of channel degradation, and listener factors on human spoofing detection performance. We used the latest synthesis technologies found in ASV Spoof 2019, and the sample lengths varied from 1 to 5 seconds. I've attached the link at the end of this presentation where you can listen to the sound files. 4 female and 4 male samples were randomly selected for each synthesis quality. We used a subset of synthesis systems identified in Wang et al. And degraded the speech to simulate 3 channel conditions under which spoof speech may be encountered in the real world. So first of all, let's look at the synthesis quality. In Wang et al.'s 2020 research, they reported a varied perceived quality from human listeners in the spoof data between the different spoofing systems. We therefore chose a subset of these systems, 3 neural network-based text-to-speech systems, covering the range of possible qualities in a spoofing attack. The system coded A10 was regarded as the highest perceptual synthesis quality. The system coded A07 was regarded to have a medium or a middle range perceptual synthesis quality, and the system coded A08 was seen to have the lowest perceptual synthesis quality. Looking at channel quality, we considered 3 common channel degradations and compared them to clean audio with no degradations. Firstly, to simulate the VoIP condition, a Zoom call was set up between 2 computers with Clumsy 0.2 running at the receiving end. Clumsy was used to modify the network to simulate a poor IP network transmission. Clumsy was set to drop with chance at 85%, and this resulted in distortions to the speech caused by the dropped frames. To simulate the GSM condition, the GSM AMR codec platform was utilized. The lowest bit rate of 4.75 kilobits per second was used to simulate a poor quality connection. Lastly, a recording of background noise in a crowded restaurant was mixed with the speech samples at a suitable level to mimic real-life conversation in such an environment. Using Qualtrics, an online listening test was set up. Listeners were presented with a total of 32 samples in a random order. In other words, 2 samples of every possible combination of synthesis quality and channel quality were used. Both male and female voices were used for each condition to provide a repeat trial for the participants, and repeated playback was allowed. The listening test was set up in 4 stages. The first was the biographical stage, where basic biographical questions were asked. The second was the trial stage, where participants were given 2 practice tests before beginning. And the third stage was the testing stage. At the beginning of this stage, there was a role-play scenario to encourage engagement. Following this, the questions were randomized to reduce the learning effect. Listeners were asked to rate each sample on a 7-point synthetic to human Likert scale. The last stage was the debrief stage. Here, participants were asked about any technical challenges experienced. They were asked to rate their confidence and describe the equipment used and the environment that the test was taken in. Something that worked really well was giving the participants a score at the end, which made it competitive amongst friends and colleagues. We analyzed the results in R using generalized linear mixed effect models fit by maximum likelihood, or GLIMER. A categorical model was chosen as opposed to using the Likert scale data. A total of 179 participants from 25 different countries took part in the study. The main hypothesis was that the human spoofing detection accuracy would decrease as the synthesis quality improved and the channel quality got worse. The results support this, as the best quality synthesis was consistently judged as more human than genuine speech, and with the perceptual distance between synthetic and genuine speech decreasing in the presence of channel degradation and noise. It appears that the features that listeners use to distinguish between genuine and spoof speech lose some of their discriminatory potential in the presence of channel degradation. Overall, participants only correctly identified human and spoof speech 56% of the time, which concerningly is only 6% above chance level. Looking specifically at background noise, we hypothesized that the speech signal would be masked and participants would get distracted by the noise interference. The results bear this out, and interestingly, all speech qualities were rated as more human in background noise than in the clean channel, suggesting an effect of the background noise on the perception of even genuine speech. As the restaurant noise was made up of largely speech noise, it may act as an informational as well as an energetic masker. As we know, audio recordings used in forensic casework are often corrupted by large amounts of background noise, which further just reiterates how important it is for analysts to use caution when working with such audio. The results from the simulated GSM channel were similar to adding background noise. However, genuine speech was rated as less natural in the simulated GSM channel, suggesting spoofing detection in a GSM channel is unreliable. We hypothesized that the synthesized speech would be incorrectly classified as genuine speech due to the frequency limitations, and the results support this. Perhaps the way the signal is encoded and the resulting frequency limitations make it difficult to differentiate between synthetic and genuine speech, as useful discriminatory parameters of the speech signal are lost. In the VoIP condition, we hypothesized that all audio would be classified as more synthetic due to the associated frame and packet loss. The results support this, as all speech was judged as less human. This may indicate that the type of interference expected by listeners primed to detect spoofing attacks corresponds to the type of interference produced in a VoIP channel, leading to reduced accuracy overall. Using clean audio, Wang et al. Highlighted that synthesized speech could be incorrectly classified as genuine speech by human listeners, particularly for the good quality text-to-speech synthesis, and our findings support this. According to Wang et al.'s study, the good quality synthesis was also able to fool ASV systems. It is clear that speech synthesis technology has improved to such an extent that critical listening alone is no longer sufficient to determine authenticity. This has implications for forensic casework, as it appears both humans and ASV systems can be fooled. This research also considers the listener factors which may contribute to an individual's spoofing detection performance. It was found that there was a significant effect of the listener's country of socialization on the accuracy of their authenticity judgments. UK participants who scored in the top 25% most often identified as having standard British English, RP, or a Scottish dialect. As most of the speakers in the audio had the same accents, these listeners were therefore familiar with the accents used in the test. Based on research into the other accent effect, accent familiarity may be an indicator of one's ability to judge the authenticity of speech. Phonemes and lexical items with subtle diagnostic value could be picked up, thereby improving their authenticity judgments. The interaction between channel quality and age was also statistically significant. Older adults were slightly better at authenticating mobile phone calls, while younger adults were better at authenticating VoIP speech. This may be because older adults defer to phone calls, while younger adults have greater exposure to VoIP-like speech in modern communication tools. Quite interestingly, when background noise was added, younger adults had increased accuracy. This may be because younger adults could selectively pay attention and discriminate the target voice, while older adults might have had increased sensitivity to masking, but further research is recommended. The interaction between audio equipment and synthesis quality was also statistically significant. But perhaps surprisingly, listeners using speakers rather than headphones were better at detecting good quality spoof speech. Further research is also required, but it's likely related to the characteristics of the playback environment and its interaction with the characteristics of the synthetic speech. We also noted some general trends in the research, but they were not considered statistically significant. Firstly, listeners' confidence is a poor predictor of accuracy. Participants who were absolutely sure that they were not fooled seem to be least accurate. This is in line with previous speaker identification studies and further demonstrates that confidence is not a good predictor of accuracy. Secondly, individuals who listen to the audio the fewest times produce the most correct scores. This suggests that initial impressions are often correct, and it also suggests that highly diagnostic information can be found at the segmental and suprasegmental level, despite the short length of samples. Thirdly, we expected linguists to outperform naive listeners. The trend suggests that linguists display slightly higher levels of accuracy than that of naive listeners. Phew! And lastly, some individuals were highly accurate, even under degraded conditions, which shows the variability of performance across listeners. Based on this research, there are many new research opportunities. We think it would be beneficial to determine if a full auditory and acoustic analysis of good quality synthesized speech, conducted by trained forensic speech scientists, would be sufficient to accurately determine authenticity. We would also like to conduct similar tests in a more controlled environment to remove the effects introduced by the lack of control over equipment. As the restaurant scenario comprises largely of speech noise, it would also be interesting to perform a similar study comparing the effect of informational and purely energetic maskers, such as white noise, on spoofing detection performance. Lastly, it would be intriguing to investigate the correlation between human participant scores and ASV scores when the channel quality is manipulated to a similar degree. This study corroborates Wang et al., as state-of-the-art text-to-speech has the capability to produce synthetic speech that is perceptually indistinguishable from genuine speech by human listeners. This study suggests that channel quality affects individuals' judgments of authenticity to such an extent that even bad quality synthesis can sometimes prove successful at fooling listeners. Also, a listener's accent, age, and the audio equipment used affect performance. Despite being aware that spoof speech was present, participants were still fooled, as they were only correct 56% of the time, which is further demonstration of the realism of the latest speech synthesis technologies. If you'd like to try out the listening test and get a score, then follow the first link. But if you prefer to just listen to the audio samples without completing the entire test for just a few examples, then follow the second link. Finally, I'd just like to thank you for listening. This research was conducted whilst doing my master's at the University of York, so I'd also like to thank Philip Harrison and Amelia Gully, who helped and guided me so well throughout this entire process. Thank you.